Section 9.5, Solving Nonlinear Inequalities. So we're not going to have equal signs anymore. We're going to have inequality symbols like less than, greater than, and so forth. So if you have a less than symbol or greater than symbol, you're going to use parentheses to show that you do not include that point. Normally in the past we would use an open circle. Now we're going to try and use a parentheses. If you had a less than symbol or greater than symbol, you're going to use a bracket to show that you do include that point. In the past we used a closed circle. Now we're going to try and do a bracket instead. So to graph nonlinear equalities, what do we need to do? First step, put it in standard form with ax squared plus bx plus c on one side, 0 on the other side, and one of these symbols from this box will go in between. So you're going to have an inequality symbol. Step 2. Pretend you have an equal sign and solve the quadratic equation by factoring if you can. Step 3. Divide the number line into parts by plotting the solutions from step 2. So you're going to break up your number line into intervals, and you're going to choose a test point. That's step 4. If the test point makes the original inequality true, then shade where that test point is. If the test point makes the original inequality false, do not shade where that test point is. Most of the time these go in a skipping pattern, so it'll be like a yes shade, then a no, and then a yes. But there are always some circumstances that don't follow the rules, so be careful to check every interval. And number 5, write the solution in interval notation. Solve and write the solution using interval notation, then graph the solution on the number line. Number 1, x squared plus x minus 6 is less than 0. If we follow the steps on the previous page, we're going to pretend we have an equal sign. So x squared plus x minus 6 equals 0. Then we're going to see if it's factorable, and it does factor into x plus 3 times x minus 2 equaling 0. Set each factor equal to 0, and we're going to get that our breaking points are negative 3 and 2. So on the number line, here's 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We'll go ahead and put the tick marks on our number line. Here's negative 3, and here's positive 2. So we'll draw a line down at negative 3 and a line down at 2. So hopefully you see that we have 3 different intervals: the left, the middle, and the right interval. So what I'd like to do is I choose a test point in between if I can. Well, the test point I'll choose is x equaling 0. So my test point is going to be x equaling 0. If 0 works, I'll shade in between the negative 3 and 2. If it doesn't work, then I'll shade on the outsides, but I'll still do test points to make sure. Where do I test? Back into my original. My original was x squared plus x minus 6 has to be less than 0. I'm going to plug in a 0 and see if it's true or false. So plugging in a 0 for x, I'm going to see is that true. 0 squared is 0, plus 0 is 0, minus 6 is negative 6. Is negative 6 less than 0? True. Negative 6 is less than 0, so the middle interval is a yes. If I try the outer pieces, I'll see that they don't work, but I should do a test point on the outside. So say for instance your test point TP on the outside could be x equaling 3. You'll see that doesn't work. And on the left side you could choose x being say negative 4. You'll also see that that does not work. So the outer pieces do not work, just the inner piece does. Then you'll have to decide should you have parentheses or brackets. So looking at the inequality, I see that I did not have an equal sign. I just had strictly less than. So I need a parentheses on the negative 3 and a parentheses on the 2. So no brackets needed here. Then it says, let's go ahead and write an interval notation. Interval notation says go from left to right and show me what you shaded. So from left to right, I went from negative 3 to 2, and that's considered interval notation. Number 2, x squared minus x minus 12 is greater than or equal to 0. First step is to pretend we have an equal sign. So we're going to have x squared minus x minus 12 equals 0. We'll try and factor it. And the factors of negative 12 out to negative 1 are negative 4 and 3. So we get x minus 4 and x plus 3 equaling 0. Setting each factor equal to 0, I would get x equaling 4 and x equaling negative 3. So again, here's my 0. 1, 2, 3, 4, there's 4. 1, 2, 3, 4, there's negative 3. I'll put a line down at negative 3 and a line down at 4. So I'll still do a test point of x equaling 0. So my test point will be x equaling 0. 0 is in the middle, so if 0 works, then I'll shade in the middle. If it doesn't, then I'll do test points on the outside to see if they work on the outside instead. So I'm going to plug in a 0, so 0 squared minus 0 minus 12 is supposed to be greater than or equal to 0. Well, this tells me that negative 12 is greater than or equal to 0, which is not true. So 0 did not satisfy that inequality. So let's try a test point on the right side. So test point TP, I'm going to let x be 5, because 5 is to the right of 4. Let's see if 5 works. So plugging that into my original, 5 squared minus 5 minus 12 is supposed to be greater than or equal to 0. Well, 5 squared is 25. Minus 5 minus 12, is that true or false? Well, that's going to give me an 8, and 8 is greater than or equal to 0, so this would be true. So this side should be a yes, which means the other outside piece should be a yes. But just to make sure, you should possibly try in plugging in, say, negative 4. So I'll need to shade this direction, put an arrow to the right, shade towards the left, and put an arrow. Then we have to decide, should we have brackets or parentheses? Well, looking at our inequality, we had the equal sign with it. So we should include those starting points. So bracket at 4, opening up towards the way you shade, and bracket at negative 3, opening up the way you should shade. So now we need to do interval notation. So interval notation says go from left to right and show me what you shaded. So I've shaded from negative infinity to negative 3 with a bracket. Put a U in between, that means a union. So, or, what's the next piece you shaded? From 4 to infinity. So all of this, so negative infinity to negative 3 with a bracket, union, meaning or, then the next piece is 4 towards infinity, so 4 to infinity. That's how you write interval notation when they're separated. Number 3. X squared minus 6x is greater than negative 5. So I do need to get it to have a 0 on the right hand side, so I'm going to add over the 5. So x squared minus 6x plus 5 has to be greater than 0. Then I'll pretend I have an equal sign, so x squared minus 6x plus 5 equaling 0. Then I'll try and factor. If they're not factorable, I'll use quadratic formula, but these should be factorable. Factors of 5 that up to negative 6 are negative 1 and negative 5, so it factors into x minus 1 times x minus 5. Setting each factor equal to 0, I get x equaling 1 or x equaling 5. So here's 0, 1, 2, 3, 4, 5, 6. There's 1, there's 5. So draw a line down at 1 and a line down at 5. So now you'll see that 0 is not in the middle. I can still test 0, but it's going to be testing the left-hand side. So if I wanted to do a point in the middle, a test point in the middle between 1 and 5 would be like 2. If you want to try 0, that's great too. Just know 0 is on the left-hand side. So test point of 2, I'm going to go back to the original. So I get 2 squared minus 6 times 2 is supposed to be greater than negative 5. Well, I get 2 minus 12 is supposed to be greater than negative 5, which is not true. So my test point 2 was a no. So let's go ahead and try 0. Test point of x equaling 0. Plugging in 0, I get 0 squared minus 6 times 0 is supposed to be greater than negative 5. Well, 6 times 0 is 0, and 0 squared is 0, so I get 0 is greater than negative 5, which is true. So the outer piece worked, so most likely the other outer piece would work too. Just want to choose a test point, say test point x equaling 6, and try it as well. So I'll shade to the right, put an arrow, shade to the left, and put an arrow. Then we decide, should we use a bracket or parentheses? Well, looking at our inequality, it was strictly greater than, does not have an equal sign, so it's going to be parentheses, opening up the direction that you're shading. So now we need to write interval notation. So from negative infinity all the way to 1. Don't forget to put a union. And then we're starting again at 5, and we're going all the way to infinity. So negative infinity to 1, parentheses, union 5 to infinity, again with parentheses. So number 4, x squared minus 16 is greater than or equal to 0. We'll pretend we have an equal sign, so x squared minus 16 equals 0. That's factorable, or you could use the square root property. If I add over the 16 and then take the square root of both sides, not forgetting plus or minus, I would get x equaling plus or minus 4. If you want to factor it, certainly you can do so. So I'm going to have a positive 4 and a negative 4 on the number line. Again, draw your dotted lines down so you can see your intervals. 0 is in between, so I'll go ahead and do a test point, TP, of x equaling 0. Plugging into the original, I get 0 squared minus 16 is supposed to be greater than or equal to 0. This would say negative 16 is greater than 0, which is not true. So the inner piece is a no. What number should I try on the outside? Would be a 5 or negative 5. And if I try a 5, 5 squared is 25, and 25 minus 16 is greater than or equal to 0. So I know that it's going to be a yes to the right and a yes to the left. Will I use brackets or parentheses? I look at the inequality symbol, and it does have the equal sign, so I want to have a bracket to show that I do include those points. So then interval notation says go from left to right. So from left, negative infinity to negative 4 with a bracket, union, a bracket, 4 to infinity. Number 5, x squared minus 4x plus 4 is less than 0. There are always some quirky ones that come up, so this is just one I wanted to show you what's happening with this problem. So we do pretend we have an equal sign, so we'll have x squared minus 4x plus 4 equals 0. So we can find our breaking points. The factors of 4 that up to negative 4 are negative 2 and negative 2, so this is going to factor into x minus 2 times x minus 2. And we're only going to get one breaking point, which is x equaling 2. So here's 0 on the number line, 1, 2, 3. So we're going to look at two different intervals, the left side and the right side. So let's choose a test point. My test point is going to say be x equaling 0. So when I plug in a 0, I get 0 squared minus 4 times 0 plus 4 is supposed to be less than 0. Let's see if it's true. 0 squared is 0, minus 4 times 0 is 0. I get 4 is less than 0, which is false. So x equaling 0 was a no. So let's go ahead and just try a point on the right hand side. Let's do another test point. Let's do x equaling 3. So test point of x equaling 3. So we'll try the right side. Plugging in a 3, I get 3 squared minus 4 times 3 plus 4 is supposed to be less than 0. Is that true? Well, 3 squared is 9, 4 times 3 is 12, plus 4. 9 minus 12 is a negative 3, and negative 3 plus 4 is 1. Is 1 less than 0? No. So the left side didn't work, and the right side didn't work. So we can't shade to the left or to the right. Because my inequality symbol was strictly less than, we can't even say it equals 2 either. So therefore, my final answer is there's no solution to this inequality. So be careful when you have inequalities. Check the left, check the right, or check all three intervals and see if any of them do work. Once in a while, you might have a no solution, or you might have an infinitely many solution. So just be careful.